In this video, we will compare the contents of the LabArchive's notebook with the local directory app demo created by the ArchiveFlow app prototype in the last video. So here we have the DSST test notebook in LabArchives. All of the metadata you're about to see has been synthetically generated for the purpose of this demo. However, the surgeries and behavior widgets, which are essentially HTML forms that serve as mini web applications in LabArchives, are intended to be parsed by the ArchiveFlow app. The metadata you see is fake, the forms are real. Here we have an NWB-compatible surgery widget. This form contains all of the metadata needed for the subject-specific portion of an NDX fiber photometry file. The goal of the app is for the user to fill out the form once and then let the app parse the form automatically when creating the final NWB file after the project is published. When the app synced the archive demo folder, which is, again, this one, with the local app demo directory, the data in these entries were automatically parsed by the app and reformatted in a JSON file in the surgeries directory. So now that we've had a look at what's inside of this form, let's navigate to the surgeries directory and open up those JSONs in VS Code. Switch to Finder. We will navigate to surgeries, cohort 1. There's implant JSON and the injection JSON. Let's load up VS Code. And here you can see for this one, the injection information is missing, but it does indeed have the implant information for the injection. You're going to see that it's the opposite. Here we have the injection and the implant data is missing. So that is as it should be. So now let's take a look at the behavior form for cohort 1. So we'll navigate back to LabArchives. We're in our ArchiveFlow behavior baseline. This widget has an initial metadata section followed by 2 tables. There's table 1, table 2. The first table is for experimental settings for behavior experiments, and the second is for fiber photometry or miniscope settings. The widget has the information is going to be parsed and copied as 2 CSV files, one for each table, and a metadata JSON. Essentially, this allows the local folder to contain a backup for all the LabArchives metadata for all the experiments. So let's navigate and prove to you that the behavior data does exist on the local directory. So we're going to back up to behavior, cohort 1, baseline, and you'll see that there is a metadata JSON. Load up VS Code. You'll be able to see that that information was parsed, and then you'll be able to see this first table, which was the box settings for the behavior. And then the second table is the fiber photometry settings. All right. So finally, what we need to do to move the app forward is to put a TDT tank directory into the TDT binaries folder for cohort 1. For this demo, we'll be using the LabArchives example data to demonstrate how the application parses the TDT tanks. So here we're going to place the FIFO data into the TDT binary folder, and then what we're going to do is refresh the experimental status and the batch processing page. I'm going to navigate to fiber photometry, cohort 1, the TDT binaries, and off screen I'm going to copy that example data over, and we will see if the application was successful in detecting it. Update our cohorts, and you can see now that the number of tanks for cohort 1 has indeed increased by 1. Found analyzable tanks. It's processed to data extraction. So if we try to batch extract the tanks, you're going to find an error that it's going to please correct the following tank directory names, indicating that this does not have the correct naming schema. When I worked with the Tejeda group to come up with a regular expression pattern so that the name of the tank is going to correlate with the name of a subject. So off screen, I am going to rename this particular one to a subject name and the date time in the format that TDT software uses. So here we'll rename it. And then we will refresh the application page. Let's update these cohorts again. All tanks are named correctly, and you can see that it is extracting the cage number, number of subject, and subject ID, as well as the absolute path. So normally we would select channels here, but the batch processing is really for when you're needing to extract the stream data into the application of a large number of phybophotometry tank directories. For a small number of files or with tank directories that would have different stream names, we have the manual extraction page. And so what this is going to do is it's going to detect that cohort 1 is the only cohort that has any tanks in there, so that's the only option. The second thing it's going to do is it's going to allow you to select the tank directory, and then it's going to show you in this JSON style what the number of subjects is, the cage number, and so you can manually confirm that this is being parsed correctly. And then when we try to extract the TDT binaries, you can see that it senses that this is the first of one subject in the file. And then it wants you to select the TTL stream. Unfortunately, the TDT example data does not have a TTL stream. So we're going to demonstrate what happens when you try to use the wrong stream and demonstrate that the app will validate the data before it proceeds. So here we have an electronic stimulation stream, so we'll try that. Isobestic is 405, experimental is 465. Let's see what happens when we try to assign the incorrect stream to the TTL. It's going to throw an error that says stream data have different lengths. And so what we can do is we can specifically label this tank as having different stream lengths. So if you accidentally use the wrong stream, save the wrong stream, or if a stream gets cut off during data transfer, you can label these tanks as having different stream lengths. So what this is going to do is it's essentially going to hide this data by default from further analysis in this application. Unfortunately, I don't have any published data that I can show you that has the TTL stream. So in the next video, I'm going to demonstrate the analysis features of this application using synthetic data that I've generated for the demo.